Download this code from codegive.com, link in the description below. Object-oriented hierarchy, a deep dive with code examples. Object-oriented programming, OOP, revolves around the concept of objects, which are instances of classes that encapsulate data, attributes, and behavior, methods. A powerful aspect of OOP is the ability to organize classes into a hierarchy using inheritance, leading to more maintainable, reusable, and extensible code. This tutorial delves into object-oriented hierarchy, covering its principles, benefits, and common patterns, illustrated with Python code examples. 1. Core concepts: inheritance, polymorphism, and abstraction. Before diving into hierarchies, it's crucial to understand the foundational OOP concepts that underpin them. Inheritance. A mechanism where a new class, the derived class or subclass, inherits attributes and methods from an existing class, the base class or superclass. This establishes an is-a relationship. For example, a dog is an animal. Inheritance promotes code reuse by avoiding the need to rewrite the same code in multiple classes. Polymorphism. The ability of objects of different classes to respond to the same method call in their own way. This allows you to write code that works with a variety of objects without needing to know their specific type. A common example is a speak method that behaves differently for a dog, a cat, and a cow. Abstraction. The process of simplifying complex reality by modeling classes based on essential features and hiding unnecessary implementation details. Abstract classes and interfaces help define a common structure and ensure that derived classes implement specific methods. 2. Types of object-oriented hierarchies. Object-oriented hierarchies can take various forms, each with its own use cases. Single inheritance. A class inherits from only one base class. This is the simplest type of inheritance and is supported by many languages, including Python. Multiple inheritance. A class inherits from multiple base classes. While powerful, multiple inheritance can introduce complexities like the diamond problem, discussed later. Python supports multiple inheritance. Multilevel inheritance. A class inherits from a derived class, which in turn inherits from another class. This creates a chain of inheritance. Hierarchical inheritance. Multiple classes inherit from a single base class. 3. Code example: building a hierarchy of animals. Let's create a hierarchy of animals to illustrate these concepts using Python. Explanation: 1 animal, base class. Defines common attributes, name, species. Speak is an abstract method. It's meant to be overridden by subclasses. The not implemented error ensures that subclasses must provide their own implementation. *_str__ provides a string representation of the animal object. 2 mammal, derived class. Inherits from animal. Adds a fur_color attribute. Super, .__init__, name, species equals mammal, calls the animal's constructor to initialize the inherited attributes. Introduces the give_birth method, specific to mammals. Notice how it doesn't need to implement speak, because animal is not marked as an abstract class. If animal had been an abstract base class, ABC, subclasses like mammal would have to override the methods marked abstract. 3 dog and cat, derived classes. Inherit from mammal. Add specific attributes, breed, eye_color. Override the speak, method to provide their own sound. Asterisk introduce their own specific methods, fetch, per. Asterisk self.species is also overwritten to give a more specific species. For bird, derived class. Asterisk inherits from animal. Asterisk adds a feather underscore color attribute. Asterisk overrides the speak, method. Asterisk introduces the fly, method. Key observations asterisk. Asterisk code reuse asterisk dog and cat inherit the name and species attributes and the underscore str method from animal, avoiding code duplication. Asterisk specialization asterisk dog and cat specialize the speak, method to their own sounds and add their own behaviors. Asterisk polymorphism asterisk the for loop demonstrates polymorphism. The speak, method is called on different animal objects, and each responds in its own way. The code doesn't need to know the specific type of the animal, it just calls the speak, method. Asterisk super, asterisk the super, function is used to call the parent class's constructor and initialize inherited attributes. This ensures proper initialization of the base class. Asterisk abstraction asterisk the animal class provides a general abstraction of an animal. 4. Abstract base classes, ABCs, and interfaces. Abstract base classes, ABCs, provide a way to enforce a certain structure on subclasses. They are useful for defining interfaces or contracts that derived classes must adhere to. Explanation asterisk. Asterisk ABC and abstract method asterisk the ABC module provides the ABC, abstract base class, and abstract method decorators. Asterisk abstract methods asterisk at abstract method marks a method as abstract. A class with abstract methods cannot be instantiated directly. Asterisk enforcement asterisk subclasses of shape must implement the area, and perimeter, methods, or they will also be considered abstract and cannot be instantiated. Interfaces, implicit in Python. While Python doesn't have a strict interface keyword like some other languages, example Java, you can create interfaces implicitly using abstract base classes with only abstract methods. This defines a contract that implementing classes must adhere to. For example, a flyable interface could have an abstract fly method, and classes like bird and airplane could implement this interface. 5. Multiple inheritance, potential challenges and mitigation. Multiple inheritance allows a class to inherit from multiple base classes. While powerful, it can lead to issues, particularly the diamond problem. The diamond problem asterisk. In this example, if D doesn't override method, which version of method should it inherit? Both B and C inherit method from A. Python uses the method resolution order, MRO, to determine the order in which base classes are searched for a method. Mitigation strategies asterisk. Asterisk avoid multiple inheritance, if possible consider composition or interfaces, ABCs, as alternatives. Asterisk explicit method resolution asterisk override the conflicting method in the derived class and explicitly call the desired method from a specific base class using super. Asterisk mixins are classes that provide specific functionality and are designed to be combined with other classes using multiple inheritance. They often define small, reusable behaviors. 6. Benefits of object-oriented hierarchies. Asterisk code reusability asterisk inheritance eliminates redundant code by allowing derived classes to inherit and reuse attributes and methods from base classes. Asterisk maintainability asterisk changes to a base class automatically propagate to derived classes, simplifying maintenance and reducing the risk of errors. Extensibility new classes can be easily added to the hierarchy without modifying existing code, making the system extensible. Polymorphism allows you to write generic code that works with objects of different types, increasing flexibility and adaptability. Abstraction hides implementation details and provides a simplified view of the system, making it easier to understand and use. Organization hierarchies provide a clear and logical structure for organizing classes and their relationships, improving code readability and understandability. 7. Design considerations for effective hierarchies. Is a relationship. Ensure that the inheritance relationship represents a true is a relationship. A dog is a mammal, but a car is not a engine. Liskov substitution principle. LSP subtypes should be substitutable for their base types without altering the correctness of the program. In other words, if a function expects an animal, it should work correctly with a dog without any surprises. Favor composition over inheritance. While inheritance is powerful, overuse can lead to brittle and inflexible hierarchies. Composition, creating objects of other classes within a class, can often provide a more flexible solution. For example, instead of having a flying car class inherit from both car and airplane, you might have a car class contain an airplane component that enables it to fly. Keep it simple. Avoid overly complex hierarchies with deep inheritance chains. A simpler hierarchy is easier to understand, maintain, and debug. Open/closed principle. Classes should be open for extension but closed for modification. Inheritance and polymorphism support this principle by allowing you to add new functionality without changing existing code. Single responsibility principle, SRP. Each class should have a single, well-defined responsibility. 8. Conclusion. Object-oriented hierarchies are a fundamental tool for building robust, maintainable, and extensible software. By understanding the principles of inheritance, polymorphism, and abstraction, and by following good design practices, you can create well-structured hierarchies that promote code reuse, reduce complexity, and improve the overall quality of your software. Always consider the design principles, the is a relationship, and alternatives like composition to create the most effective and maintainable solution.